Hello friends, welcome to the video lecture series of Engineering Mathematics 2. In last video, we traced polar curves. Now in this lecture, we are going to discuss how to trace the rose curve. Okay, these are the polar curves again. But why I am calling it as a rose curve? Because these curves looks like rose, therefore I am calling it as a rose curve. Now in rose curve, two types of curve we are going to discuss. R equals A sin n theta, R equals A cos n theta. If n is even, then number of loops will be 2n. Here n is positive integer. And if n is odd, then number of loops will be n. If n is even, number of loops 2n. If n is odd, number of loops will be n. Now R equals A sin 3 theta. This curve we are going to trace. Is first of all, we are going to discuss the characteristic of this curve. Number of loops R equals A sin 3 theta, and this curve is of the type R is equal to A sin n theta. Here n is free, therefore number of loops are 3. Here in this curve 3 loops will be there. Now, whether this curve passes through the origin or not, that I am going to check. Yes, for at least one value of theta, R is 0, then that curve passes through the pole. All rose curve passes through the pole. If curve passes through the pole, then we can find out the tangent at pole. How to get the tangent to the pole? So put R is equal to 0. If you substitute R is equal to 0, what will happen here? Then sin 3 theta equals 0. So 3 theta equals sin inverse of 0. And sin inverse 0 is multivalued function. The sin inverse 0 is sin 0 is 0, sin pi is 0, sin 2 pi is 0, sin 3 pi is 0, and so on. Now these are the values of 3 theta. What I am going to do, I am going to divide it by 3. 0 by 3, then pi by 3, 2 pi by 3, 3 pi by 3, 4 pi by 3, and so on. These are the tangents at pole. In examination, the tangents at pole to the curve may be asked in examination. Is this curve symmetric about initial line? Initial line means theta equal to 0 line. This line is theta equal to 0 and we call it as the initial line. And this vertical line is theta equal to pi by 2. And the vertical line in opposite direction is theta equals 3 pi by 2. This line theta equals pi. So I am going to check the symmetry. Symmetry reduces the work of curve tracing. The R equals A sin 3 theta. If you look at this curve carefully, I am going to check the symmetry. If I replace R by minus R and theta by minus theta, in properties of the polar curve in previous video, all those properties just I explained. Now R equals minus R equals A sin of 3 theta. Okay, this sin function is odd function. We can write like this: minus of sin 3 theta is sin of minus 3 theta. Now sin goes away. R equals A sin 3 theta. On replacing R by minus R and theta by minus theta, the equation of the curve remains same. Therefore, curve is symmetric about the line perpendicular to initial line. This vertical line completely is perpendicular to the initial line, and to this initial line, this curve is symmetric. Now, how to find out the region of the curve? In which region curve lies? Say R is equal to A sin of 3 theta. In rose curve, two types of rose curve we are going to study. And if you look at these two equations, then we have the periodic function sin and cos only. And the maximum value of sin and cos is 1, because the sin and cos function, they are in between minus 1 and 1. The maximum value of sin and cos function is 1, minimum value is minus 1. R is the radial distance, the minimum value I will be taking 0 and the maximum value will be what? So what I am going to do, the maximum value of sine function is 1. So R equal to A is the region. In this region a curve will lie, and R is equal to A it is a circle of radius A. It is the circle of radius A. See, R is under root of x square plus y square. Just if I take square of both the sides, x square plus y square is A square. Okay, this is the circle with center 0, 0 and radius A. Radius is A, and this is the region of this curve. Means in this region the curve will lie. In a circle of radius A, the curve lies. Okay, by freehand I am drawing circle. Okay, exact circle you will not find out. Just only for the sake of understanding, I have drawn this circle. And in this circle, this curve will lie. This curve is symmetric about this vertical line. This vertical line is the line which is perpendicular to initial line. Means on the right hand side of this line and on the left hand side of this line, the same portion of curve will be there because of symmetry. So what I will be doing, I will be finding values of R for the values of theta which are present in this first and fourth quadrant. This is symmetric about the vertical line, this curve is symmetric about this line. Then it passes through the pole. Here R is 0 and theta is 0, therefore it is called the pole. This is the tangent, theta equals 0. This is pi by 6, then it is pi by 3. This is theta equal to pi by 3. All those lines I will not be using because those lines lies in left hand side of this vertical line, and since the curve is symmetric about the vertical line, the left hand side portion I will not press. I will draw it by symmetry directly. Now pi by 3 is, this 2 pi by 3 is the tangent, pi is also tangent. 3 loops we are going to press. Now what to do? So for different values of theta, we want values of R, but in optimistic way, just few values of theta I will choose, and for those values of theta I will find out the values of R. Now since the curve lies on the right hand side, this curve is symmetric. Since the curve is symmetric about the vertical line and right hand side portion of the curve I am going to draw. So right hand side value of theta I will be putting here. See, here theta is equal to 0 I am putting. This occurs on the right hand side of this, theta equals 0. Then what are the tangents? This is the tangent, this is pi by 6, this is pi by 6, 2 pi by 6, 3 pi by 6, 4 pi by 6, 4 pi by 6, this is 5 pi by 6, this line is 6 pi by 6, this line is 7 pi by 6, 8 pi by 6, 9 pi by 6 is 3 pi by 2. Then 10 pi by 6, theta equals 10 pi by 6. Then theta equals 11 pi by 6. Theta equals 12 pi by 6 means theta equals 2 pi. Theta equals 2 pi and theta equal to 0 is the same initial line. So for some values of theta, I am going to find out values of R. So theta equal to 0 I have taken. Now, just you see the tangents here. Pi by 3 is the tangent. 2 pi by 3 is the tangent, then pi is the tangent, then pi by 3, 2 pi by 3, 3 pi by 3, 4 pi by 3 will be the tangent, then 5 pi by 3 will be the tangent, 6 pi by 3 will be the tangent, this will be the tangent again, and this is the tangent. All these red lines are the tangent I have drawn. Theta is equal to pi by 3 I will not take here. Theta is equal to 2 pi by 3, theta is equal to pi, theta is equal to 8 pi by 6, theta equal to 10 pi by 6. Those values I will not take here. Because for those values of theta, R is 0. Here we have written for these values of theta, R is not 0. For these values of theta, R is 0. Means these are the lines which are tangents to the curve at O. Because these values I will not put here. And suppose if I put here, then corresponding value will be 0. That you can write it directly. Theta is equal to pi by 6 I am taking. For theta equal to pi by 3, its value is 0. No need to write. For theta equal to pi by 2, how do you make the sectors, that are also I tell you. See, here the number of sectors, pi by 2n is a sector and n is 3. 2 multiplied by 3 means pi by 6. The in multiples of pi by 6, pi by 6, 2 pi by 6, 3 pi by 6, 4 pi by 6, 5 pi by 6, pi by 6, 7 pi by 6. In multiples of pi by 6, you may draw the line. Is it? Now, for pi by 6, we can find out the value of r. Is it? Now, for theta equal to 0, if you put theta equal to 0, the value of r is 0. That is very clear. For theta equal to pi by 6, r equals a sine 3 theta. And for theta equal to pi by 6, what will happen here? R equals sine pi by 2. And sine pi by 2 is 1. The value of r is a. For theta equal to pi by 2, you can take r equals a sine 3 pi by 2. And sine 3 pi by 2 is minus 1. The r equals minus a. So I am putting here r equal to minus a. Since the symmetry is being used, on right hand side part of this I am going to trace. Therefore, left hand side values of theta I will not make use of. For theta equals 3 pi by 2, what will happen? R equals to a sine 3 and 3 pi by 2. Okay, you may use calculator to get the values. Sine 9 pi by 2 and sine 9 pi by 2 is 1, because you can use the calculator here to get the value of sine 9 pi by 2. Can you find out the value of r at theta equal to 10 pi by 6? No, because this red line is a tangent. 10 pi by 6 is a tangent. Okay, pi by 3, 2 pi by 3, 4 pi by 3, 5 pi by 3 means 10 pi by 6. 10 pi by 6 is a tangent. Okay, the value of for r I am not going to write here. Value of r for theta equals 5 pi by 3 is 0. That we have written here. Then come to this value. Theta equals 11 pi by 6. This value of theta equals, if you put theta equals 11 pi by 6, what will happen here? Sine 3 theta, and this is a sine of 11 pi by 2. And the value of sine 11 pi by 2, use calculator. Value of sine 11 pi by 2 is minus 1. And the value of r is minus a for this one. And for theta equal to 0 or theta equal to 2 pi, the r is 0 again. How many points we are going to plot? 1, 2, 3, 4, 5. That's all. You may take many values of theta. It is your choice. But the minimum value of theta you try to use and get the curve. On theta equal to 0, r is 0 means this point. This point is point O, I am calling it as point for convenience, This is point O. Is it? Next point is A point. For theta equal to pi by 6, value of r is A. For theta equal to pi by 6, the value of r is A. Is I have drawn a circle of radius A by freehand. So this point I have obtained, and name of this point for convenience I have given A. For theta equal to pi by 2, r is minus a. Exactly in opposite, yes, I am putting r is equal to a. For theta equals 3 pi by 2 for this one, what is the value? 3 pi by 2 value of r is a, means this point again. Is it? For 11 pi by 6, value of r is minus a. For 11 pi by 6, this is 11 pi by 6, value of r is minus a, means exactly in this point only. the points which occurs on the left hand side of this vertical line, we are not going to bother about it because I am using symmetry to trace the curve or draw the curve directly. How many loops are there? 3 loops are there. Now, see, we have to join these 2 points so as to form the loop. While forming the loop, you keep in your mind that pi by 3 is a tangent. These 2 points, in order to form the loop, in this way we can join. It is not sure that at this point we have continuity or discontinuity. That we can check, is it? So what I am going to do, and if I draw the tangent, then this theta equal to pi by 6 and the tangent line will be perpendicular to each other. If there is a single tangent at this point, then the path of the curve will be continuous curve. Now I am going to check it whether we have the single tangent or not. If at this point, if 2 tangents, it will be the node point. And node point is what? The discontinuous point. In previous lecture we discussed. At node, we have the discontinuity. Single tangent occurs at this point, then you will have the continuity while tracing the curve. Okay, that you can check it very, very easily. Phi is angle between radius vector and the tangent. And how do you find out the phi? Tan phi equals r d theta by dr. This is the formula for tan phi. You can remember it. Now, r d theta by dr value I am putting. So I am finding d theta by dr here. Take different derivative of r with respect to r, which is 1. A is multiplicative constant. Derivative of, I am pressing this curve. Derivative of this is cos of 3 theta multiplied by 3, and derivative of theta with respect to r is d theta by dr. Therefore, d theta by dr equals 1 by 3a sine of 3 theta. D theta by dr is 1 by sine of 3 theta. Then r equals, r is a sine 3 theta. D theta by dr is 1 by a cos 3 theta. So this is cos 3 theta. And this is cos 3 theta. And value of r is what? A sine 3 theta. This divided by 3a sine 3 cos 3 theta. Then this a gets cancelled. 1 by 3 tan of 3 theta will. Is for theta equal to pi by 6, what will happen? Tan of 3, theta is pi by 6, and it will be tan 3 2s are 6, tan 3 pi by 6 means tan pi by 2, and tan pi by 2 is infinity. The tan of pi by 2 is infinity. The value of tan phi is coming to be infinity. Theta by dr indicates the slope. Okay, if slope is coming to be infinity, line which is tangent to the curve at this point will have infinite slope. Will have infinite slope means these 2 lines will be perpendicular to each other. Therefore, this is the tangent to this one. And if it is a tangent, then you can have the smoothness in the curve, smoothness in the loop, Okay, this is the point of continuity. We have no discontinuity there. Theta equal to pi by 3 is a tangent. Theta equal to 0 is a tangent. See, since the curve is symmetric about vertical line, the exact same loop we have to draw here also, due to symmetry only. Due to symmetry only, the part which is present on right hand side of this vertical line, the same loop will be here because of the symmetry. This you can draw directly. This loop I have traced, but this loop you can draw directly because of symmetry only. Now, there are 3 loops, the 2 loops we have drawn. Now the next one. Theta is at 3 pi by 2, value of r is a. So there are chances to have a loop at this point. Again, this loop I'll be getting this type of loop, you know. You can check the tangent at this. In this way we have traced the curve.
Thank you very much.